So I was saying that in the previous class we started going towards the end of the second chapter, okay, and today we are going to continue from there. In the previous section, when I started talking about capacitors to you, I said you what is the meaning of the word capacitor. What are capacitors? I said you capacitors are the electrical devices that are used to store energy. And how they store energy? By storing charges. So by storing charge, they store energy. What happens if you have any conductor that is charged? Listen to me very carefully. Any conductor that is charged is a capacitor, because work done to make the charge go on the conductor only is the energy stored inside the capacitor. Am I right? If you have a particular conductor and you make it charged, some work has been done to make the charge go on the capacitor. That work done only is stored as the energy of the capacitor. Am I clear to you? Next, I told you, if you bring another uncharged plate near a charged plate, then the potential reduces. And since capacitance is equal to Q by V, if V is reducing, capacitance will increase, right? So how do we make capacitor? We take a charged conductor and we bring uncharged conductor near to it. By the principle of mutual induction, automatically it will also become charged in some time. And then if you are putting earth in the second plate, the potential further reduces and the capacitance further increases. Please keep these things in your head very sharply, that if you want to make a capacitor, what you need? First you need a charged plate. Charged plate itself is a capacitor. You bring uncharged plate, its capacitance increases. You make earthen of uncharged plate, the capacitance further increases. I think you remember all these points. I told you about capacitance formula, which was equal to C is equal to Q by V. Q is in coulombs, V is in volt. Coulomb per volt is called as what? Not joules, farad. Farad is the SI unit of capacitance. Yes.
Sir, what you are trying to say was that reduced resistance means increased capacitance.
Reduced resistance I not said. I said reduced potential means increased capacitance. Because the formula is C is equal to Q by V. If you reduce voltage, obviously capacitance will increase.
Then does it have any relation with resistance?
See, in a way V is equal to IR. So from Ohm's law, if resistance will reduce, if the current is constant, then obviously V will increase. But when the resistance will reduce, current will increase, no man. So V remains constant. Are you getting my point? So don't think that if R reducing, V will reduce, C will increase. If R reduces, current will increase. In a circuit, if you are reducing the resistance, what will happen? Current will increase. If current is increasing, IR remains constant. Conservation of energy. Are you getting my point? So don't think that reducing the resistance will reduce the potential, will increase the capacitance. Not like that. But if you have a charged plate and you bring an uncharged plate near to it, because of the principle of induction, this becomes negative and this becomes positive, that will reduce the potential for sure. I gave the example in the previous class to you, 100 volt, 80 volt, 60 volt, remember? And then if you do some earth in here, this will also be removed. Then further potential reduces, further capacitance increases, and that's how we make capacitors. So for generally, whatever capacitors we have in market, they will either be parallel plate capacitor, or they will be spherical capacitor, or they will be cylindrical capacitor. These are available in market. If you see all these three capacitors, what we have? We have two plates and one plate is earthen, isn't it? I am once again repeating, I am not saying to you that a single charged plate is not a capacitor. This also is a capacitor. It will be called as isolated plate capacitor. Single sphere also is a capacitor. Isolated spherical capacitor. Single cylinder also is a capacitor, isolated cylindrical capacitor. But if you want to have an efficient capacitor where your capacitance is very good, then you must have parallel plates and one plate must be earthen. I think these things I taught in the previous class to you itself. Also, I remember I gave you the formula of capacitance, which is equal to 4 pi epsilon naught R, isn't it? And I could explain you by this formula how much big is 1 farad. Because capacitance, if you take 1 farad, the radius required to store 1 farad of capacitance will become 9 into 10 to the power 9 meters, which is 1000 times bigger than the earth's size. So for 1 farad capacitance, you need a capacitor 1000 times like bigger than Jupiter capacitor you need. So we always talk about capacitance in terms of nanofarad, microfarad, picofarad, which is 10 to the power minus 9, 10 to the power minus 6, 10 to the power minus 12. Isn't it? So up to here we have seen till the previous class. So Varshita Shri, you should not have your video off, please. Coming back. So now we are going.
The network stored here, so I will on again.
Okay, please check your connection and camera should not go off for anybody. I am repeating this point. We will have to put you in waiting room otherwise. Coming back. So today's class, what is the agenda? Today we are going to try to finish the chapter itself. And what are things we are going to learn today? Today we are going to learn in detail about parallel plate capacitors. That is there in the syllabus. Spherical is not there, cylindrical is not there. We are going to learn about how the capacitors are connected in series and parallel, how they behave. Today we are going to learn about how much energy is stored inside the capacitor. And at the end, we will learn about how to further increase the capacitance of a capacitor. Already, by introducing an uncharged plate, you increase the capacitance. By putting earth in, you increase the capacitance. There is one more way, which you imply further capacitance will increase. Today we are going to learn about that method also. Are you ready today? What is the plan of class? Okay. So first you give the heading as parallel plate capacitor. Today's first topic is parallel plate capacitor. So I hope everybody understands the meaning of the word parallel plate capacitor now, which is you have a plate which is a charged plate and you brought uncharged plate in front of it and did earthen of this plate, so only negative charge is remaining here. Am I right? This is a typical parallel plate capacitor diagram where I have two plates, one plate is positively charged, another plate is negatively charged. Can I say that if it is positively charged plate, it has a charge density of plus sigma? Sigma is equal to charge per unit area. I hope you are realizing it is in 3 dimensions, it is like this. Don't think it is a wire, it is a plate. It is fully positively charged plate. It is fully negatively charged plate. So I am saying its charge density is plus sigma, its charge density will be minus sigma. Do you agree with me? Sigma is charge per unit area. I think this thing comes in the previous chapter. So in the previous chapter, in the application of Gauss law, I taught to you if you have two plates which are having charge densities of plus sigma and minus sigma, what is the electric field between them? Did I teach you? Loudly. Sigma by 2 epsilon naught is for only single plate. If you have two plates, it is sigma by epsilon naught. 2 into 2 sigma by 2 epsilon naught, it will become sigma by epsilon naught. Outside 0. You remember this? If you have plus sigma, then inside 0, outside sigma by epsilon naught. So remember that in between this, that is if I am having two plates which are charged like plus and minus, having charge density of plus sigma and minus sigma, in between them I will have electric field, uniform electric field, and this electric field value is sigma by, I think everybody will agree with me. Some of you may be little new who have not learned the previous chapter, may have little difficulty, but for now you can understand, you can remember this. I will teach anyhow. So electric field is sigma by epsilon naught. Also in this chapter, in the previous class, I told you the relationship between electric field and electric potential, where I told you that electric field is always equal to electric potential by distance. Did I say this to you? E is equal to dV by dr minus dV by dr, isn't it? So electric potential can be written as what into what? Electric field into distance. Am I right? So by that I can write here potential is equal to electric field times distance. Let me take distance as d. Between the plate, if I take distance as d, then you can understand that the value of potential will be E into d. I will give time for writing. Learn now. Writing can be done even by seeing the video. Please learn now how what I am doing. Understand the concept. So electric potential became what? E into d. So electric potential is equal to E is what? Sigma by epsilon naught into d. In the previous class we learned capacitance is equal to charge per unit voltage potential. So can I write charge as sigma into A, because sigma is equal to Q by, this is the formula of sigma. Sigma is surface charge density, it means charge per unit area. So charge will become sigma into A divided by what is V? V will become equal to sigma into D and epsilon naught will go above. Do you agree? Sigma sigma gets cancelled. You get the capacitance of a parallel plate capacitor as epsilon naught A by D. This is the formula, like how we told the formula of isolated spherical capacitor as 4 pi r epsilon naught. Same way, the capacitance of a parallel plate capacitor is epsilon naught A by D. Pay attention, epsilon naught is permittivity of free space, A is the area of the plate and D is distance between the plate. So this is the distance between the plate, D, area will be this area. Are you getting my point? Clear? A is the area of the plate, D is the distance between the plate, epsilon naught is the absolute permittivity, also called as permittivity of free space. Its value is 8.85 10 to the power minus 12. Am I right?
Excuse me, sir.
Please tell me, Pratap, please.
Sir, by area do we mean area vector or just area?
Just area, the value of area. Now we are dealing with scalar quantities, man.
Okay, sir.
Okay. If you are done, understood, copy 2 minutes, fast. If you have understood this, copy in 2 minutes. Don't take more than 2 minutes. Are you done? Are you done? Can I proceed?
Yes, sir.
Thank you, Anshul. Anybody else who has yet to finish? Fast, fast, fast. So the first kind of question that comes in the examination, the most easiest question, least expected also, is that what will happen to capacitance if the distance between the plate is halved? What will happen? Distance are double. What will happen to the capacitance if area becomes double? Capacitance will become double. What will happen to the capacitance if the area becomes half and capacitance distance becomes double?
1/4.
Hey, listen. Distance become double, area became half. So 1/2, you can get it to 1/4. It will become 1/4. Like that, we can, this kind of questions anybody can solve. So it will not come in the exam. Okay. So now pay attention to what is going to come in the examination. Right. So what I am going to do now, I am going to connect these capacitors in series or parallel. Shall I? So can I go to the next page now? If everybody agrees, if you have something to write, you can write it later. I am going to the next page now, where I am going to talk to you about capacitors, which is the parallel plate capacitors in series and parallel. Capacitors in series and parallel. Once again, I will give time for writing. Have patience, drop your pens, listen, understand the concept. It is a very simple concept. Just pay attention properly. So very similar to resistances as you have studied in 10th standard. They can be in series or parallel. Even the capacitors can be connected in series or can be connected in parallel. So you can see very clearly how I am drawing. You will get an idea that if you connect the capacitors in series, it means plus sigma minus sigma, plus sigma minus sigma, plus sigma minus sigma. Are you getting the connection? Plus minus plus minus plus minus plus minus. That is the connection in series. If you are connecting in parallel, plus sigma plus sigma plus sigma together, minus sigma minus sigma minus sigma together. This connection is called as parallel connection. So what is series connection? What is parallel connection? I hope everybody understands this. Now, the moment I apply external potential, so here I can put a battery for providing the external potential. Same way here also I can put a battery to provide the external potential, because I know that the moment I provide the potential, then I will have the charge flowing, and charge goes, capacitors becomes charged, and then energy is stored inside the capacitor. That is the use of capacitor. Now, listen to what I am saying. This is coming from again 10th standard, that in series connection, potential always gets divided. Same thing happened in 10th in resistance also. So, here we will have some potential, here we will have some potential, and here we will have some potential. V1, V2 and V3. And net potential V will become equal to what plus what plus what? V1 plus V2 plus V3. It is applicable to any electrical device. Resistance is there, inductor is there, capacitor is there, whatever it may be. The potential always gets divided. What she is writing, Shweta? Listen, I will give time for writing. That time what you will do? Talk. Please pay attention. So, potential gets divided for each capacitor. Now, what is the formula of V? Q is equal to CV, or C is equal to Q by V. We know that Q is equal to CV. So, what will be V? V will become Q by C. I am assuming capacitors of capacitance C1, C2 and C3 are there. Now, one thing you should understand, like the resistors, current remains same in series connection. Here what will remain same, you know? Charge will be same in this Q, Q and Q. Plus sigma, minus sigma, plus sigma, minus sigma, minus, plus sigma, minus sigma. So, charge remains same. If charge remains same, it will become Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. Take Q and cancel it, you will get 1 by C series is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Exactly opposite of what happened in resistors. In resistors, if they were in series, you got R series as R1 plus R2 plus R3. Here I am getting 1 by C series equal to 1 by C1 plus 1 by C2 plus 1 by C3. What you should remember? You should remember that in series connection, potential may be different, but charge remains same. What will happen in the case of parallel connection? potential remains same, charge will be differing. So Q1 charge may be there, Q2 charge may go here, and Q3 charge may go here, C1, C2 and C3. So the net charge Q will become equal to Q1 plus Q2 plus Q3. So whatever charge is coming, it will equally divide, right? So now what is Q? Q is equal to CV. So I will write C parallel into V is equal to C1V plus C2V plus C3V. Why I have taken V same? Because V, I said you, in parallel connection V remains same, it will not change. V take out common, cut it, you will get C parallel is equal to C1 plus C2 plus C3. This is the capacitance of parallel plate capacitors kept in parallel connection. So exactly ulta of resistors. There in parallel you had 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here you had in series. There in series you had R1 plus R2 plus R3. Here you have in parallel. In next chapter you are going to have resistors in series and parallel also. In 12th standard you will have capacitors in series and parallel, resistors in series and parallel, inductors in series and parallel, batteries in series and parallel, everything will be in series and parallel. So have clarity about which case what is happening. Am I clear? So if you are clear, copy it fast. Don't take much time. Please copy fast. Saravanan, your video is off, man. You should not off your video. Saravanan S from Gudvancheri. I hope it is done. Can I proceed further? Now,
Yes, sir.
how the questions can be asked in the examination. Please pay attention. Now, don't expect the question to be as easy like though it is easy, but solve it. 2 microfarad, 4 microfarad, 4 microfarad. What is C equivalent? Tell me fast. Solve it, everybody. Simple question. Solve it. Four and 4 are in parallel. 2 is in series with 4 and 4.
Sir, 1.6.
1 point.
1.6. 5 by 8 micro.
5 by 8 is not 1.6 man. Check.
Sir, 8 by
5 by 8. Five by 8 is the final answer. Everybody says, huh? 8 by 5. 8 by 5. Okay. 8 by 5. Final answer 8 by 5. Forward reciprocal. I hope you are realizing this 4 and 4 are in parallel. If they are in parallel, they will become 2. Sorry, 8. So it will become like 2 and 8 in series. So if you have 2 and 8 in series, then you will have 1 by C equivalent is equal to 1 by 2 plus 1 by 8. LCM is 8. So it will become 4 plus 1. 1 by C equivalent is 4 by 8. So C equivalent will become 8 by 5 microfarad. Isn't it? But don't worry, this question will not come. How it will come? Take it. Shall I make it a little complicated? Simple only. Everything is C, C, C and C. What is C equivalent? Careful, good question. Next question also I will write here. Solve this question first and that question second. This will be more easy. Anyhow, your wish. In both the questions, you have to find C equivalent between A and B. Server I, your camera is off and I think you have not filled the form yet, right Saravanan? I told you to fill the form. You have not yet filled the form. Your login is still not created itself in the app. I am talking to you Saravanan, you can unmute yourself.
I log in, sir.
I don't want you to log in man, first to fill the form, then only you can log in.
Okay, sir.
Please, today after the class gets over, fill the form, okay?
Done, sir.
Done. What is the answer for the first question, Pratap?
2 by C plus 2C, sir.
Tell me finally, yeah, 2 by C plus 2C is how much? Solve fully. Yeah. And second question?
And second question is 3 by C. 3
Oh.
by C, sir.
Okay, that is his answer. Anybody here?
Sorry, sir. C by 3.
C by 3. Okay. Here any answers? I am giving 2 more minutes. Make it fast.
Sir, 5C by 3.
5C by 3. Okay. I'll check it.
Sir, I changed my answer for the first one, sir.
What is your answer now?
5C by 2, sir.
5C by 2. Okay. Anybody else? Any answer? Shall I solve now? Shall I? I'll solve this question first, then I'll go to that question. Easy. You are thinking easy, but no, nobody would have got the correct answer, I know. Let me check. First thing, Saravanan, Thambi, don't off your camera always, please. Nitish Raghav, camera should be on. Coming back. So, always remember, this is applicable to capacitors, batteries, resistors, inductors, any electrical device. If in the circuit you have a device coming, only then the potential can change. That is, if you have a potential VA, it will be VA, it will become VB here. Until you have any appliance coming in the path of the potential will not change. So, if this is A, 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 this is also A. If this is B, B, this is also. Now, I am going to draw A and B. This C is between what and what? A and B. This C is between what and what? A and B. And this C is between what and what? A and B. So, here we have 3 capacitors in parallel. So, what is the answer? 3C. I don't think anybody said 3C. Did you get it? Very important, learn this. What I did, I took the potential A. I cannot write here as A because here some appliance is coming. But here see, nothing is coming, nothing is coming. If I would have had some appliance here, then I cannot write this as A. It will happen here. So, please.
So why it can be in series?
Why can't it be in series, you are asking? Series means charge should not divide. Are you getting my point? If charge gets divided, it is in parallel. So, here charge comes, charge will not be going same in all the 3. capacitors, because it has another path to go. Are you seeing that? So they are not in series. Same way here, this is A, this point will become A, this will also be A, this will also be A, and nothing else. Here B, this point will be B, this point will be B. Anyhow, they are same only. Now if I draw here this point, let me take this point name as D, because already C I am using for the capacitance. So I have 3 points here, A, D and B. Pay attention, what I am teaching is actually very useful for competitive exam itself. Pay attention. This C is between what and what? Between A and D. So between A and D I am drawing one C. This C is between once again A and D, so I am drawing one C. This C is between A and B, so I am drawing between A and B. This C is between B and D, so I am drawing between B and D. Understanding? Anything remains? This C, this C, this C. Tell me, Kirti, something you are asking?
Can you repeat it once?
I will repeat once again. Did you understand, Kirti, how I have given this name A, B and D?
Yes, sir.
Okay. So what I did, I wrote A, D, B, and each capacitor I am trying to locate, it is lying between which and which points. So this capacitor was lying between A and D, so I am drawing one capacitor between A and D. This capacitor also lies between A and D, so I am drawing between A and D. This capacitor lies between A and B, so I am drawing between A and B1 capacitor. This capacitor lies between B and D, so I am drawing one capacitor between B and D. Understanding, Kirti?
Yes, sir.
I hope. Now this C and C are in parallel, it will become 2C, so I am going to get one C, here one 2C, once again a C, C, 2C and C. Is it clear? Now 2C and C are in series, so I am going to write 1 by C equivalent is equal to 1 by C plus 1 by 2C, which will become LCM as 2C, it will become 2 plus 1. So 1 by C equivalent will become equal to 3 by 2C. So C equivalent will become 2C by 3. So I will redraw once again, one C is there and one 2C by 3 is there. So one 2C by 3 and one C. So when you solve this in parallel, you will add both. So answer will be C plus 2C by 3, which is equal to 5C by 3. Is it clear to you? Is it clear to you? Nobody told the answer as 5C by 3. Got the answer after I taught this question? Before that? Then you should have told, no? What, Devadarshan, something you are saying? Okay, then fine. But this concept is clear to you how I have solved. Is this concept clear to you? By this concept, many questions can be solved. Yes, somebody is saying something? So this is the way the questions can be asked in the examination, series and parallel. They will give you complex connections and they may ask you to solve it and get the answer. Shall I give another question for solving? Shall I? NCERT book is there? It does not have questions for series and parallel. Nothing is there. One very famous question is this. this is 40 microfarad, this is 60 microfarad, this is 10 microfarad, this is 10 microfarad, 60 and 60. Find the C equivalent between A and B. Please solve it. Simple question actually. If you are able to understand, it's a simple question.
Sir, can you say the farad values again? So it's little blur.
Once again, Revan sir, you can go for that mode, screen mode. Once again, not at here, you have to click in the yellow pro box. That second you click, if you click here, no? Anshul, visible now clearly?
Yes, sir.
It's simple question. Please try to solve it. Yeah, what are you saying? 17, 17.
20, sir.
20. Okay. 20 microfarad is the answer by Devadarshan and Niranjan here. Anybody else? Anybody else? Kirti, what is happening at school? Which chapter are you teaching now? In physics?
This second chapter.
Okay, same thing what I am teaching, the same chapter.
Yes.
Okay, okay. Shall I solve this or you can solve by yourself? I'll give you a hint. 60, 60, 60 are in series. So it will become equal to 1 by C equivalent is equal to 1 by 60 plus 1 by 60 plus 1 by 60, which is 3 by 60, which will be 1 by 20. So you will get C equivalent is equal to 20 microfarad. Same way, this 10 and 10 are in parallel, it will become 20. So I am going to have 40 here, and then I am going to have 20 here, and I am going to have how much? 20 here, and then these two are connected like this, isn't it? 20 and 20 are in parallel, it will become 40. So you are going to have 40 and 40 in series. Simple question. So 40 and 40 in series will make it 1 by 40 plus 1 by 40, which will become 2 by 40, which is 1 by 20. So answer is 20 microfarad. Good. Simple question. Simple question. It has come in the board exam also. But simple question, isn't it? So once you are able to crack series and parallel, it is simple topic. Can I proceed further? Sure? Okay. Then give the heading as dielectrics and polarization. Dielectrics and polarization. Shall I proceed? Okay. Now please pay attention. Everybody pay attention. What is the meaning of the word dielectric? Anybody knows? Voltage.
Sir, conducting medium. All conduct.
No.
Medium with two conduct is called dielectric, sir.
No. So it is what? Insulator. Okay. Dielectrics can also be called as insulators, but you are unfortunately in 12th standard. So they want to make you sound big. Dielectrics is just insulators. Okay. We have conductors, insulators. We can say in 12th standard as conductors and dielectrics. Are you getting? Because dielectric looks heavy. It's on record also. Okay, anyhow. So dielectrics are just insulators. Now I am going to study about the behavior of insulators as well as conductors when they are placed in electric field. Very important thing. So imagine you have a uniform electric field. See, by these many days of classes, you must understand that uniform electric field can be produced if you have two plates, one is having plus sigma, one is having minus sigma, between them sigma by epsilon naught is the uniform electric field. That is only called as capacitor also. Am I right? So you are going to have a conductor. Let me assume it is a conductor which is placed inside what? Which is placed inside uniform electric field. I want to study about its behavior. Everybody be concentrated, nothing to write now, understand the concept. Very important thing I am teaching now. So you will get questions from assertion and reasoning from here. So concept should be very clear for this. What happens? You know, the moment you have, what you have? You have two sigma plus sigma minus sigma plates, you get electric field, how much? Sigma by epsilon naught. If you have sigma by epsilon naught electric field, what is the behavior of conductor? Conductors are those materials which have free charged particles, am I right? They are only responsible for conduction of electricity and heat because they have free charged particles. Now these free charged particles can be positive or negative. You know very well that all the positively charged particles will start moving along the direction of electric field, and all the negative charged particles will start to move against the electric field. So in this conductor, all plus will accumulate this side, all negative will accumulate that side. Are you able to understand this point? I had a uniform electric field. Suppose this wall is positive, this wall is negative. Positive to negative we have a electric field. Here I am keeping a conductor. If I am keeping a conductor here, all the positive charge moves towards your right because they are having tendency to move in the direction of electric field. All the negative charge will move towards left because they have a tendency of moving against the electric field, which will create electric field in the opposite direction. Can you feel that? Plus, 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 minus, 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 minus. You are getting some opposite electric field here inside. This is called as E polarized or E induced, whatever you want to call it. Now this polarized electric field will cancel the applied electric field, and inside the conductor the net electric field will become 0. It means if you have a conductor placed inside the electric field, there will be no electric field inside the conductor. This property is called as electrostatic shielding. Electrostatic shielding, also called as Faraday's cage. These kind of heavy words if you hear, don't confuse. It is this thing whatever I am teaching now. Faraday's cage. So it is a condition where you keep a conductor inside uniform electric field, and then inside the conductor there is no electric field. You know, it is said that if you are in a car and you have a heavy raining day and too much of lightning is there, the safest place is inside the car with all the things locked. Even if lightning strikes your car, since you are sitting, assuming that car is metallic body, assuming that it is metal, so it will be conductor, so it will fall on you. Everywhere electric field will be there, but inside electric field will not be there. You will be safe. This property is only known as electrostatic shielding because inside no electric field. Now let us study the behavior of insulator. See, it's very strange actually, you know. Now what is insulator? Insulator is the materials which have very, very less free charge particles. Don't think that no free charge particles. In reality, insulators or dielectrics will have very less charged particles, not enough, but little will be there. Now since little are there, if I am going to keep the insulator here, those little charged particles will move like this, am I right? And they are going to create electric field in the opposite direction. But this electric field will not be strong enough to cancel the applied electric field. The polarized electric field in the case of conductor was strong enough to cancel the applied electric field. That's why electric field became 0. But in the case of insulators, also called as dielectrics, the E polarized will not be strong enough. So I should say that E polarized is less than E applied, and so net electric field will be how much? E polarized, actually E applied minus E polarized. Can I write like this? E applied minus E polarized. Are you understanding this? But since here E polarized was equal to E applied, the net electric field became 0. So when a conductor is placed inside electric field, it will have 0 electric field inside. But when you have insulator placed inside electric field, it will have some electric field inside the insulator. We have learnt recently that electric field is electric potential by distance. If you had a capacitor, we have some electric field here. If I insert insulator inside it, insulator will decrease the electric field because E net will become E applied minus E polarized. If electric field is reducing, electric potential will reduce. If electric potential is reducing, capacitance will increase. That is why we are keeping dielectric inside the capacitor. Dielectric inside the capacitor leads to reduction in electric field. Reduction in electric field reduces the electric potential. Less electric potential will increase the capacitance. Is it clear to you? Next topic is this only. Next topic is effect of dielectric inside the parallel plate capacitor. But now you are understanding what is happening in a dielectric. In dielectric, the electric field is reduced. Are you getting my point? Clear? Okay. Then copy whatever you want to copy from here. It is just about behavior of conductors and insulators in uniform electric field. What I have taught now is behavior of conductors and insulators in uniform electric field. Copy it fast. Nitish Raghav. I took your name. At least you should unmute here. Nitish Raghav.
Sure.
Yes, you are from SRM school, right? No, Sriniketan. Oh, you are Sriniketan. Okay, okay. I thought you were SRM. SSM school, when are they going to start the vacation? Anbarasi? Summer vacation.
In April, sir. Yes.
Yeah, do you have summer vacation? You have summer vacation, right? When it starts, any idea? Which date?
27th, sir. I'm not sure about it, but 27th of April.
Ah, okay. LWA, I think for you it is 25th of April, am I right? LWA, there are 3-4 people. Anybody can unmute and say.
Not sure, sir, but I guess so, sir.
Okay. What about Mithun is from SRM, I think. Yes, Mithun, tell me.
Sir, I think from May starting or April end, sir.
Okay, not sure about the date still.
Yes, sir.
Okay. Blessing school, Sarvana.
Sir, from April 25.
Okay. Fine, fine. I hope you have copied. Can I proceed further? Shall I proceed further?
Copy, sir.
Thank you, Saravanan. I heard your voice after a long time. Shall I proceed? Guys, here. Okay. Now let us talk about the polarization concept. I not talked anything about polarization now, I just talked about dielectrics, its behavior in electric field. Now let me ask you, please pay attention. Again, something from where the questions can be asked in assertion and reasoning in the board examination. Okay. Now, tell me what are polar molecules and non-polar molecules? Anybody can tell me? Anybody, chemistry experts here, can tell me the difference between polar molecules and non-polar molecules? Huh?
Polar molecules is a dipole moment.
Okay, and non-polar molecules will not have dipole moment. Good. You are correct. Give me an example of polar molecule, Mr. Niranjan.
HF, hydrogen fluoride.
Okay. And example of non-polar molecule?
Methane.
CH4. Ada, so he told the same thing. Anything else? You are going for some hi-fi chemistry. I am not that much knowing, huh? H2O.
Sir, H2 will have dipole.
Yes, H2O will have dipole moment. Carbon dioxide, non-polar. Hydrogen, H2, not polar. Oxygen, O2,
All diatomic.
obviously. Concept says that if you have any molecule, molecules means more than one atom, until it is not monatomic, more than one atom. Then if there is some separation between their positive and negative centers, it gives rise to dipole moment, because dipole moment is positive and negative having some separation, right. So if you have a molecule, for example HCl, even HF, if you have HCl, H is small, Cl is large, am I right? If you see their positive and negative centers, it will have separation between them. Positive and negative will have some separation between them, and this leads to formation of dipole moment. This kind of molecules like HCl, like water, they have separation between their positive and negative centers, giving rise to dipole moment, and these kind of molecules are called as polar molecules. On the other hand, if you have O2, two oxygen atoms having same size, similar structure, so their positive and negative center will be coinciding. If it is coinciding, no separation between positive and negative, so no dipole moment. Understanding? But here dipole moment is there, it is not 0, and here I can say that dipole moment is 0. Obviously I can say. Why dipole moment is 0? Because there is no separation between positive and negative centers. Carbon dioxide, non-polar. Water, polar. For the molecule to be polar, there should be separation between its positive and negative centers. That's all. Understanding? Now, please pay attention. Now we came to know that if I am having HCl molecule, I am going to have dipole moment. If I am going to have oxygen molecule, I am going to have no dipole moment. If I am having a container filled of HCl acid, do you think it will have dipole moment? No. You know why? Because now on a matter level, dipoles will be arranged in random directions. Am I right? Why the dipole moment should be in the same direction? It may be in random directions, and since they are in random directions, they will be cancelling each other, and net dipole moment will once again become strange. HCl on a single molecule level having dipole moment, same HCl in a matter level having no dipole moment, And obviously if you have a container filled with water, what actually is polar? Oxygen or maybe carbon dioxide, then dipole moment will be 0 only, because there is no dipole itself. So on a molecular level, HCl shows dipole moment, oxygen does not show dipole moment, but on a matter level both of them don't show dipole moment. Okay, now what I am going to do, I am going to apply electric field. So the same thing, I am going to apply external electric field. Now what will happen? Can you feel what will happen? The moment you apply electric field, dipoles have a tendency to align in the direction of electric field, right? Torque will act, turn the dipole. We have studied in the previous chapter. So these dipoles will start aligning like this. Are you getting? In the direction of electric field, which will create some dipole moment. Now the dipole moment once again is not equal to 0. Strange thing is, for a non-polar molecule, matter, negative and positive is together, negative positive together, but electric field will start pushing positive this side, negative this side, right? Which will create some dipoles here also. Are you getting? Not as strong as the polar molecule substance, but it will also have some dipole moment. So whether it is polar molecule or non-polar molecule, at matter level they don't have dipole moment, and when they are subjected to electric fields, they both get dipole moment. Clear to you? Net dipole moment per unit volume, net dipole moment per unit volume is called as polarization. It is a vector quantity, P by V. So what will be its unit? Unit will be P, dipole moment is Coulomb meter, and volume is meter cube. So the SI unit of polarization will become Coulomb per meter square. Which other quantity has same unit? This question came in the board exam. Which other quantity has same unit as polarization? Surface charge density, sigma. Q by A, charge by area, isn't it? So sigma has same density, same unit as polarization. So polarization is equal to net dipole moment per unit volume. One more thing, this polarization, don't you think it is proportional to electric field? More the electric field, more the polarization. Less the electric field, less polarization. Now polarization, if you remove the constant, if you remove the proportionality, you have to add a constant. That constant is called as electrical susceptibility. Chi, it is called as chi, K-A-I, chi. Some schools will also call it chi. What you want to call? Nothing is there in that. I have seen some schools, they call it as chi. Not only schools, you go to some other countries, they will speak it as chi only. But whatever, that is secondary. It is called as electrical susceptibility. It is called as electrical susceptibility. Electrical susceptibility. So how is electrical susceptibility defined? As polarization per unit electric field. Is it clear to you? From here theory questions will come, no numericals will come. So please understand all these things. I will repeat. Dipole moment per unit volume is called as polarization. Polarization is proportional to electric field. So polarization will become equal to constant times electric field. That constant is called as electrical susceptibility, which will be defined as polarization per unit electric field. Same thing will repeat in 5th chapter, where you will have magnetization, and I will say magnetization is magnetic moment per unit volume, and I will say magnetization is proportional to magnetic field, and magnetization is equal to chi b, which will be magnetic susceptibility. So, if you are understanding today's class, you are understanding 10% of chapter 5 also. Okay, copy it fast. This is all about polarization. Done? Can I proceed further? Shall I?
Sir, just a minute, sir.
Make it fast, please. Shall I proceed further? Okay, next topic, kind of last topic in this chapter, which is very important for the board examination, because if you see last 5 years, 3 years this question has come in the board examination. Derive the expression for capacitance of a parallel plate capacitor with dielectric slab inside it. So give the heading as effect of dielectric inside parallel plate capacitor. Parallel plate capacitor. Shall I? As I always say, please don't write anything. Listen, understand. Notes is always secondary. Learning is the primary thing. Please pay attention now. So what do I have? I have a parallel plate capacitor, and I am very much aware that its capacitance was epsilon naught A by D. But for a second, forget that, because now what I am going to derive is going to serve like a mother formula. Okay, give me a second. Revan sir, you can come to that screen. Yeah. So coming back, I was saying that this derivation will be treated as the mother formula by which you can derive capacitance of a parallel plate capacitor without dielectric, capacitance of a parallel plate capacitor with dielectric, partial dielectric, fully filled dielectric, everything you can derive a single formula. So this formula becomes very important. So what I am going to do now, in this capacitor I am going to place a dielectric. Again, what is that dielectric? Insulator. Heavy word to make you depressed that you are in 12th standard. Okay. The distance between the plate is D, and thickness of the dielectric is T. Clear to you? I have taken the thickness of dielectric as T, and distance between the plate I have taken as small d. Now, just now I have taught you the behavior of insulator inside the electric field. What I have told you, if the external electric field is E, then inside dielectric we will have some other electric field. Am I right? So I am taking the electric field applied as E naught. Electric field inside electric will be E, lesser than the E naught. I told you, because this E will become equal to E applied, that is E naught, minus E polarized. I hope you remember this. Right? Okay, coming back. In the first chapter, I taught to you F naught by F is equal to epsilon by epsilon naught is equal to epsilon R is equal to dielectric constant kappa. What was this? I will recall it. I told that if the two charges are kept in free space, they will have some force between them, that is F naught. If same charges kept at same distance in some other medium, the force will change. What will be the force? 1 by 4 pi epsilon times Q1 Q2 by R square. When you divide both, you will get everything cancelled, remaining term will be epsilon by epsilon naught. This ratio is called as epsilon R, that is relative permittivity, also called as dielectric constant. Okay. You have recently learnt F is equal to QE, charge times electric field is force. So Q into E naught divided by Q into E. Q gets cancelled. So can I say that E naught by E is equal to kappa? Can I say this? E naught is the electric field when there is no medium, and E is the electric field with some medium. Am I right? Because F naught is the force between the charges with no medium, empty space, and F is the force between the charges with some medium in between. Same way E naught is electric field without medium, and E is electric field with medium. So can I say, okay, now coming back to here. So we know that electric field is equal to electric potential by distance. I have told you. From today, third time I am writing this. Electric field is electric potential by distance. So can I say that electric potential is equal to electric field in distance? Now here in this case, if you see properly, you will realize for this T, E is acting, and for the remaining distance, that is D minus T, E naught is acting. Do you agree with me? Do you agree with me? Because here the electric field is not E naught, E is there. But in the remaining region, what is the electric field? E naught. So electric field multiplied by distance only gives potential to me. But for the dielectric part I am taking T, remaining part I am taking D minus T. Any doubt in this? I proceed. V will become equal to, just now I wrote there E naught and E relationship, isn't it? So can I write E as E naught by K? E as E naught by K, kappa, which will be plus E naught into D minus T. Now I can take common what? E naught. E naught will become equal to, that is E naught into D minus T plus T by kappa. Can I write like this? I hope everybody is understanding whatever I am doing. I can further write this as V is equal to what is electric field due to the charge that the plate sigma by epsilon naught. Can I write like this? Electric field E naught is sigma by epsilon naught into D minus T plus T by K. Clear? Time to find the capacitance. I am writing it here after this, okay? Don't confuse the order of writing. After this I am writing here. So, capacitance is equal to Q by V. So, I can write this as Q is how much? Sigma into A divided by, what is V? Sigma by epsilon naught into D minus T plus T by K. Sigma sigma gets cancelled. I get capacitance as epsilon naught A divided by D minus T plus T by K. This is the mother formula I was talking about. Because now you know that if you have a capacitor in which you have a dielectric of thickness T, the capacitance has become epsilon naught A by D minus T plus T by K. There are three possibilities. First possibility is empty capacitor, that is no dielectric. Good word is no dielectric. If there is no dielectric, what is 0? T is 0. If T is 0, what will happen to C? T is 0, 0. You will get C is equal to epsilon naught A by D. Same thing we got. The same thing which we derived earlier, we got now. Next is with full dielectric. What is that? T will become equal to D. Am I right? T and D will become same. Do you agree with me? If T and D become same, C will become equal to epsilon naught A by D minus D plus, don't disturb me like this, D by K. DD gets cancelled. So C will become equal to K times of epsilon naught A by D. And if it is partial dielectric, then the formula remains same. So if you have some dielectric thickness given, use this formula. If it is fully filled dielectric, use this formula. If it is empty dielectric, use this formula. Are you getting? That's why I told, if you remember this formula, you can find the capacitance of parallel plate capacitor without dielectric, fully filled dielectric and partial filled dielectric. Is it clear to you? Important for the board examination. Okay? If okay, please copy it fast. Please copy it fast. Are you done writing? Make it fast if you are still doing. Done? All of you done? Can I go to the next slide? Sharan Ram, shall I?
Being done, sir.
Done? Done? I hope.
Yes, sir.
Yes, so some of you would have seen that you have got the portions for the examination. If you have not seen, you will see it by after going to home. So coming Sunday, it's going to be physics test only, if you don't know. Coming 6th of April is going to be your first physics test, and I have kept the portions as only chapter 1. Okay, so I am not keeping chapter 2 now. So please prepare for it and come for the test. Those who have not attended any first chapter class also, I will be keeping a session before the examination, and I have told you already, see all the videos and be ready. I am going to keep a class. You should not write any notes that time. Just see, listen, understand. Notes taking should happen from the video itself. Okay. So, yes, tell me, Devadarshan.
Only first lesson.
Only first lesson I am giving.
Okay.
Okay.
And timing, sir. Sir, timing.
Everything will be mentioned in the group. You please check there. In the WhatsApp group, you will also get the information about the chapter, date, time, not only for physics, chemistry, math, everything. By now, it would have come in the group. You can go home and check in your WhatsApp group, everything would have already come. The timetable of the examination. So, again I am repeating, take the test very seriously. Then only it will help you in improving for the examination. Next thing is assignments, that is the worksheets that you are doing on Tuesday's class. I am seeing many of you are not turning up for Tuesday's practice class itself. Don't be like that. Tuesday's practice class is more serious than this class. Here I am just teaching. There you are solving question, and that is your weak point. There only you will realize what mistakes you are doing, what you should not do, how to improve yourself. Okay. So please take the practice seriously. Always do the worksheets. Always do the worksheets and do it by yourself. Online children, don't think we are not knowing that you are copying, you are googling what you are doing. We are that much experienced that we can know how your answers are coming. Avoid doing anything like that. Do everything by yourself. So it is becoming very hectic taking the practice session after 9 o'clock. I am feeling that. So we are going to take it separately. I am planning for that, a separate session for your doubt clearing. Because already you are sitting from 7 o'clock to 9 o'clock and then once again half an hour of staying back for doubt clearing. It is a little tedious for you. For us also, because I am taking class from 6 o'clock here in the same room. So I will plan some extra sessions where I will clear doubt for all the online children. But take all the worksheets seriously. Solve everything. That is the only way you can improve yourself. Remember that we are working for a bigger goal. For the board examination, we should do well. And all of you would have got to know from your friends this year's physics test paper, how it was. I am not saying it is very tough, nobody can do. From the same paper, let the result come. You all will be here only, I will show you. Out of all children who came last year, I can assure you, 20 of them will score more than 90%. In physics I am talking. 10 of them will definitely go more than 95. In the same paper where people are telling passing itself is difficult. So, difficult is a relative term here. If you prepare hard, your difficulty will reduce. If you simply go for the examination, it will be difficult only. So, keep on working hard. I am going very slow. Reason is there for that. If I go more faster than this, no, things will go from above your head. Physics is something which should be properly taught, step by step, concept by concept. I am not here to finish syllabus for you. I am here to make you things easy for you, teach you in a way that you will understand everything. So don't have a thinking that my school is going very fast, he is going very slow. I am intentionally going slow, because if I go faster than this, you will not understand the concepts well. I hope some of you, most of you are understanding whatever I am teaching. If you have any feedback or grievances, we have given the feedback form, you can fill there, we will take some actions on that. Okay. So with all these things, I am winding off my today's class and we will meet once again in the next class. This chapter is almost done. A small thing is there, energy stored in capacitor. I will be doing it in the next class and I will start the current electricity chapter in the next session.